Hello everyone, this is a brief introduction to our paper, Mitigating Biases in Taxi Language Detection through Invariant Rationalization. I'm Yong-Song Zhuang. This work is a joint work with National Taiwan University and ITCCL and Amazon AI. Taxi language detection (TLD) is a useful technique to protect social media users from verbal abuse. However, machine learning-based TLD system usually correlates toxicity with some lexical and dialectal biases. For example, when minority identity mentions exist in a sentence, the system tends to predict toxic labels even if the sentence itself is not toxic. It means that online discussion about the minority identity will be discouraged by the social media, which is very unfair to the minority groups. So the machine learning researchers need to debias the TLD models. Previous research indicates that the existing debiasing methods still have limited results on debiasing TLD models. Motivated by this problem, we want to develop a new approach to effectively debias the TLD model. Our idea comes from a technique, rationalization. It means finding a subset of the input called rationale, which is short and coherent, yet sufficient for the model to make the same prediction. The rationale can be seen as an interpretation of why the model makes this prediction, and it should be consistent with human intuition. Now let's talk about why rationalization can help taxi language detection. In taxi language detection, if the model directly uses the whole input sentence to make the prediction, it is easy for the model to correlate some biased terms with toxicity. Now let's split the prediction process into two steps. First, we use the rationale generator to extract the rationale in the input sentence. We expect that the biased terms will be excluded in this step. Second, we use the extracted rationale to make the prediction, so the predictor here can be less biased by the spurious correlation. Now the problem is how to obtain a good rationale generator that can exclude the biased terms. Here we use a game-theoretic framework called Invariant Rationalization to extract good rationale from the input sentence. Before introducing this framework, we need to introduce a new idea, environment. We can imagine that our input data are sampled from different environments, like different dialects or different lexical attributes. In different environments, we expect that the predictive power of spurious correlation will not be stable. For example, in some environments, swear words may be highly correlated with toxicity, while in some environments, they are not correlated with toxicity. But when it comes to the causal explanation, they should always have the same predictive power, no matter what environments they come from. Now let's go back to the three-player game-theoretic framework. In this framework, we have two predictors, environment-agnostic predictor and environment-aware predictor. Only the second predictor can access to the environment information, so in principle it can achieve better performance than the first predictor. In this framework, the duty of the rationale generator is to minimize the performance gap between these two predictors. It means that the extracted rationale should be invariant to the environment, so the environment information cannot bring any advantages to the predictor. Now we can train these three models in the following steps. The first step and the second step is to update these two predictors to minimize prediction loss, respectively. In the third step, we update the rationale generator to minimize the loss gap between these two predictors, so it will try to generate rationales that can make environment information be useless to the predictor. We iteratively update these models by step 1, step 2, and step 3. Finally, we can obtain a good rationale generator and a less biased predictor. In the experiment, we use the false positive rate to measure the bias of the model. If the false positive rate is high in specific data groups, it means that the model has the biases toward these data groups. We show the results from 2 data groups: non-offensive identity mentions, NOI, and African American English, AAE. The false positive rate of these 2 groups represents lexical bias and dialectal bias respectively. On the top of this table is the results from the previous work. In the bottom is our baseline model and our proposed method. We can see a significant drop in false positive rate of our method. It indicates that our method can effectively remove the biases in the model. Here we show some examples from the rationales extracted by our model. Basically, we can see the model can find good rationales and exclude specific bias terms in the rationale. Our take-home message is, the biases in taxi language detection model can be effectively reduced by invariant rationalization. The rationales generated by this method can exclude some biased terms, and it is human interpretable. This method can be easily applied to other datasets or other domains, so it is more practical for real-world use. This is a brief introduction to our work. For more details, please refer to our paper and code. Thanks for listening.